Hello? Hello? Okay, I'm live streaming. Uh, Apparently my mic wasn't on, but alright. I want to get through this section. It's called Files in the File System, and we're going to learn about working with files and directories. So I'm going to assume they're going to create directories, remove files, create files, all those lovely things.
In previous videos, we saw how to navigate the Linux file system and look at the content of text files. In this video, we will go more in depth into the topic of files and directories and discuss how to manage them. First, let's look at the touch command. It updates the last modification time of a file to the current time. We can see the last modified timestamp on the notes.txt file using the ls command like this. To update the modification time, execute the touch command. We can see that the timestamp was updated to the current time. While we normally don't need to update the last modification time of a file, there is a side effect of the touch command that is very useful. If the specified file doesn't exist, the touch command will create it. Notice that
That's what I know it
the
as.
file
I didn't know that it
test.txt
does that.
doesn't yet exist in the working directory, but it does after we use the touch command.
So far, I've only seen it create text files.
Surprisingly, the touch command is used more to create empty files than to update the last modification time. If we want to make a copy of our notes.txt file, we can use the cp command. In the simplest example, you use the cp command, then specify the source and then the destination, like this.
Copy to the copy.
We now have a copy of the file. As you can see in the man page for CP, there are a number of options we can use. The destination can be a directory instead of a file. You can copy multiple files into a destination directory in one command. You can even use the -n argument to prevent accidentally overwriting an existing file with the copy. If we want to move the file instead of copying it, we use the move command, mv. The syntax is very similar to the cp command. We specify the source and then the destination as arguments like this.
Yeah, I've always known this, but like my attention span is very small, and I know some of this, so I'm kind of like just conversating, like instead of listening and refreshing, like I'm trying to do. To the full.
Like the cp command, there are many other ways to use the mv command. For example, the destination file name doesn't need to be the same as the original. In fact, the mv command is frequently used to simply rename a file by moving it to a new file name in the same directory. Linux does have a rename command, but it is complicated to use and is used in different situations than simply renaming a single file. If we want to delete the file we just moved, we use the rm command, which is short for remove.
RF.
Unlike when you delete a file in a file manager, deleting the file at the command line doesn't put it in a recycle bin where you can undelete it.
It's
When you
gone.
delete the file, it is gone. If you look at the man page for the rm command, you can use the -i option to prompt before removing the file to minimize chances of accidentally deleting the wrong file. Now, let's take a look at some commands that allow us to manage directories. First, the make-dir command will create a directory.
Vector.
You can see that the directory project was created. and there is nothing in it. If we decide later that we want to remove the directory, we can use the rmdir command like this. Note,
So directory, projects, project. Okay, it should be under pictures, and it's not.
the rmdir command doesn't work if the directory has files or other directories in it. It only works if the
Recursively.
directory is empty. Here we have a non-empty directory, and rmdir fails to remove it. If you want to delete a non-empty directory, you need to use the rm command used to delete a file. In this case, we add the R and F options indicating we want to recursively remove all the contents of the directory and to not ask for confirmation to delete each one of these resources.
She gone.
Lastly, if you need to rename a directory, you can use the same mv command we used on a file.
You forgot he removed it.
Most of the commands we discussed when working with files can be used with directories too. In fact, as you learn more about how Linux works, you will discover that it treats many things like a file, even things.
Everything's a file.
Most of the commands we discussed when working with files can be used with directories too.
Everything's a file. Okay, let's try that. Go CD back home. Okay, stop using that. Okay, music. Nothing in there. Probably will be nothing. So I want to make a dir slash Drake, and I want to touch, which means to update file created, and I want to call it love songs .mp3. So now I can go to LL music. There's going to be a directory called Drake. So I wonder why that last command. Oh, it did it in my current directory. So if I press LL, it'll be in my home. Watch. Love songs.mp3. So this is a good opportunity. Just learn about art. So love songs was after it. IP suite, now it would be yes. Okay. Nice.
In fact, as you learn more about how Linux works, you will discover that it treats many things like a file, even things like your mouse and keyboard.
Everything's a file.
If you are accustomed to working in a graphical environment, like Windows or Mac OS, you probably have used spaces in file names and directory names. Since you primarily interact with the files by pointing and clicking, you don't encounter any problems with these spaces. However, it is a different story if you have to work with them on the command line. Let's look at an example to see the problem firsthand. In the spaces subdirectory, I have both a file and a directory with a space in the file name. Notice that the shell displays both the file and the directory in single quotes. This is to let you know that, for example, file name.txt is one entry and not two. If we try to cat the file, we can see the problem.
It's gonna
Cat
look for
generates
two
an error
files.
saying it can't find either the file with the name file or the file with the name
Text.
name.txt. Let's try changing our directory to be mydir. CD complains that we have entered too many arguments.
You can't change the two
Both of
directories
these
at one
problems
time.
arise from the fact that the bash shell uses spaces as separators for command line arguments. As a result, the cat and cd commands both see two arguments instead of the one we intended. The easiest way to address this challenge is to not put spaces in file names. I frequently use
Yes, camel
dashes or
case.
underscores as word separators to avoid this
Yep.
problem. If that isn't an
It's the
option,
hacker
however,
thing to do.
there are two ways to tell bash the space is part of the name. The first way is to escape the space with a slash like this. The escape character tells bash to treat the space as part of the argument and not a normal separator. This works with the directory as well. The other alternative is to place the entire name in quotes. You could use single quotes as I just did, but
Okay, I already have a favorite, and I rarely use this because I just use one spaces, one file name, and it's quotes.
it is recommended to use double quotes. Double quotes tell bash you want to use the literal value in the quotes and not to interpret any special characters. Again, the best practice is to not use spaces in file names and directory names. If you don't have a choice, however, these two options can help you avoid the problems single quotes as I just did, but it is recommended to use double quotes. Double quotes tell bash.
I'm gonna try this out right
You
now.
could use single quotes as I just did, but it is recommended to use double quotes. Double quotes tell bash you want to use the literal value in the quotes and not to interpret any special characters. Double quotes tell bash you want to use the literal value in the quotes and not to interpret any special characters. Again,
That sounds like what the
the
single
best
quotes
practice is to
do.
not use spaces in file names and directory names. If you don't have
Okay, we're gonna try that. So I'm gonna touch a photo called Love Songs again. And we're gonna make a directory called space dir. So we got space directory. Alright, we're gonna move love songs to make space. List that space or we type it out and like this, which is kind of annoying. So it's gonna look so ugly, like just don't use spaces. So we're gonna delete that. File and file path expansion.
Sometimes you need to specify multiple files on the command line. You could enter them all individually, but there is a better way. The command shell provides a way to use wildcards to specify multiple files and directories all at once. This process is called file and path expansion, but you will more commonly hear it called globbing. As we have seen in previous videos, directories and files in a path are separated by a slash. Everything that is in between separators is called a segment. Unless otherwise specified, globbing only works within a single segment, like a directory.
Yeah, I'm already lost.
The most used wildcard is the asterisk. Sometimes you need to specify multiple files on the command line. You could enter them all individually, but there is a better way.
Okay.
The command shell provides a way to use wildcards
It's talking about like the asterisk.
to specify multiple files and directories all at once.
It seems complicated, but we've used it once already.
This process is called file and path expansion, but you will more commonly hear it called globbing. As we have seen in previous videos, directories and files in a path are separated by a slash. Everything that is in between separators is called a segment. Unless otherwise specified, globbing only works within a single segment, like a directory. The most used wildcard is the asterisk. It means 0 or more non-separator characters on the command line. It will accept a string of 40 characters or none. For example, let's say that you want to use the ls command to only list the text files that start with the string file. If we look at the directory, there are a number of files that match this pattern. With the asterisk wildcard, we can use the following command.
So ls file star.
Note that since the asterisk doesn't include separator characters, it won't expand into a subdirectory that starts with file. It will only expand within the current directory. As you can see, it matched the file, file.txt, where there were no extra characters, and many other files where there were. If we want to be more restrictive, we can use the question mark. It means any single character on the command line. Let's say that you only want to list the text files that start with the string file and have another character after that. Using the question mark wildcard, the command would be, if instead you wanted to search across multiple segments, you can use the asterisk wildcard. If you place it in...
So it's not listing AA because it's 2 characters. So question marks for single characters.
Wildcard, the command would be, other files where there were. If we want to be more restrictive, we can use the question mark. It means any single character on the command line. Let's say that you only want to list the text files that start with the string file and have another character after that. Using the question mark wildcard, the command would be, if instead you wanted to search across multiple segments, you can use the asterisk wildcard if you place it in front of a slash as if it were a directory.
Okay, what? Hold up. No, this is brand new to me.
If instead you wanted to search across multiple segments, you can use the asterisk wildcard if you place it in front of a slash as if it were a directory. Notice that it's searched within the current directory and subdirectories. The asterisk matches 0 or more
Wow.
characters across multiple directories. If it doesn't work on your system, you need to set the glob star option using the following command. The last technique we will discuss is the use of square brackets. Unlike the previous options, these aren't wildcards that match any character. In this case, they indicate very specific characters to match. For example, if we only wanted to match files that start with file, which is then followed by the numbers 1, 2, or 3, we could use the following command. If, as in the case here, we have a range of values, we could modify the brackets to use a range. It didn't save us much here, but if we wanted to match any letter, it would be very beneficial. In this case, it saved us from having to type out every letter in the alphabet, both uppercase and lowercase. Globbing is very useful, and you will find yourself using it more and more as you spend time on the Linux command line.
Okay, these are like specific use cases. You have tons of files. That was a lot to go over. I guess we could try some of them. Just don't have many files. So we could also do like 3 through 5 if we just had that. Okay, combine it with the asterisk. So 1 and 2, okay. I mean, this is like, I don't know, if you really have like a file system that's crazy, maybe a computer that's always on is doing stuff, creating files, doing this, doing that. Oops. Did we even finish that video?
It didn't save us much. In previous videos, we discussed a few utilities that allowed us to look at the contents of text files. Since working with text happens frequently in Linux, there are more commands you will frequently encounter, some of which we will discuss in this video. First, we sometimes only want to look at the first few lines of a text file. To do this, we use the head command. By default, it displays the first 10 lines like this.
Whoa, that's a command?
If you want to view a different
I
number,
don't
you
know,
can
look at
use the
that.
-n option. Since this is so common, head offers a shortcut where you can omit the n, like this. There is also a command to view the last few lines of a text file. The tail command shows the end of a text file and defaults to showing the last 10 lines,
So,
just like head.
constantly updating file.
For the most part, the options are similar to the head command. You can specify the number of files to display using -n, and even omit the n. The tail command, however, does offer some functionality that separates it from the head command. You will find that you often need to monitor the end of a file for changes. For example, you may want to watch the end of a log file for new log entries. For example, Linux has a log file called auth.log that records any request for authentication, like temporary elevating to administrator privileges. Let's see how we can use tail to watch the file for changes. First, we tail the log file using the -f option.
What is he saying?
Let's see how we can use tail to watch the file for changes. First, we tail the log file using the -f option. In another terminal, I will request administrator privileges to run a simple command.
You can act like you're busy.
I will explain what this is doing in a later video. Note that the auth.log file changed when I ran the command, and we were able to see those changes as they were made in the tail. The last command we will discuss in this video is the diff command. The diff command compares two files line by line and displays any differences. If there are a lot of differences between the two files, the output can be a bit difficult to decipher, but it is a great utility for finding small differences. Let's see it in action. To make the differences easier to see, all the changes are in capital letters. Whenever diff finds a difference in a line, it prints out the two lines so you can see the difference. The first line is from the first file specified as an argument and is denoted by the less than sign pointing to the left. The second line is from the second file and is denoted by the greater than sign pointing to the right. While there are a number of Linux tools that do the same thing as diff, but with a better user interface, most can't be used on the command line like this.
Oh, whoop-de-doo.
To make the differences easier to see, all the changes are in capital letters. Whenever diff finds a difference in a line, it prints out the two lines so you can see the difference. The first line is from the first file specified as an argument and is denoted by the less than sign pointing to the left. The second line is from the second file and is denoted by the greater than sign pointing to the right. While there are a number of Linux tools that
Just
do the
pointing to
same
the
thing as
file.
diff, but with a
Yeah.
better
Hey, uh, man, this is really good. Testing my patience here. I can do one more video. Hard and soft link file systems.
You are probably familiar with shortcuts in other operating systems. They allow you to quickly navigate to a file or directory elsewhere in the file system. Linux offers similar functionality through links. A link is just a reference or pointer to a file or directory somewhere on the file system. There are two types of links in Linux: hard and soft, or symbolic, links. They are both created using the ln command. Looking at the man page for the ln command, we can see that the target, or the thing we want to link to, is the first argument, and the link name is the second argument. By default, ln creates a hard link. A hard link points to the physical location of the file on storage. As a result, if the original file is moved or even deleted, the hard link continues to work. The file will only be completely removed when there are no hard links on the system to the file. Let's look at an example. Here we have a simple file, hello.txt. It contains the word hello. We can create a hard link to the file using the following command. If we edit the original file, we can see that it is reflected in the linked file. I'm going to use the Vim editor to edit the file. We will cover its use in a later video, so
Oh
don't
god,
worry
he's
about that
opening
part of the
Vim.
example right
He's
now.
opening Vim. Oh, he's showing off now. Okay, what's he doing? Okay, the original file has been changed.
We edited the original hello.txt file, but the change was visible in the hello hard link text file. If we delete the original file, the linked file still exists with the same content. Let's recreate the original file so we can use it again. Note that we can't create a hard link to a directory, as that might cause a circular loop in the file system. Hard links are older and being phased out of general use, although you will still find them used in specific situations. For example, Mac OS uses hard links in the HFS Plus file system for time machine backups. Soft or symbolic links are more commonly used. These are more similar to a shortcut in Windows than hard links.
The desktop icon.
A symbolic link references the file or directory on the file system, not on storage like a hard link. This means that if the resource is moved or deleted from the file system, the symbolic link will not work. Let's create a symbolic link to a file as an example.
Testing.
Note that the ls command indicates that the soft link we created references the original hello.txt file. We can get at the content just like we did with the hard link. However, If we move the hello.txt file, the soft link won't work and becomes useless.
So it's not even removing it, it's just renaming it.
When creating soft links, ensure that you use an absolute path name for your target. Symbolic links don't understand directories, and you need to be specific to avoid potential problems. So why would you want to use a soft link when it is more fragile than a hard link? There are a number of reasons. First, you can create a soft link to a directory. I frequently do this with software I have to manually install on a system. We can see an example here where I've created a generic symbolic link for the Java JDK that references the specific version installed on this machine. When I upgrade to the next version of Java, I can simply change the symbolic link to point to the new version, and the configuration of my programming environment will automatically use the new version. Also, soft links can cross file systems. For example, if I have my home directory on one drive partition and a file is on another partition, I can still create a symbolic link to the file in my home directory, unlike a hard link. You may not create many links as you use the Linux command line, but you will definitely encounter ones created by the system. If you pay attention, you will find that Linux uses quite a few of them internally.
Okay, I'm not really familiar with all this. Okay. Okay, can't do it from directories, it says. So let's try this. Link, soft to Alright, I mean, I get the gist, so we don't have to go too in depth. That. Okay. Alright, my PC is dying, so just have to charge it.
We have been working quite a bit with files, but we haven't yet talked about how to find them. There are a few ways to search for files and utilities from the command line. The most used utility is the find command. It is a very powerful command with a number of options, as we can see from looking at the man page. Due to the range of options available, the full usage of find is beyond the scope of this course, but we will touch on a few options you need for general from the command line. The most used utility is the find command. It is a very powerful command with a number of options, as we can see from looking at the man page. Due to the range of options available, the full usage of find is beyond the scope of
We could spend all day here. That's what he's basically saying.
this course, but we will touch on a few options you need for general use. If we look at the usage in the synopsis, we can get an idea of how to use it. For our purposes, we aren't going to be interested in the first few options. What we are interested in is the starting point and the expression. The starting point is the directory from which the search will begin. Find will not go up to a parent directory, so this limits what directories will be searched. If you want to search the entire file system, use the root directory / as the starting point. The expression option tells the find command how it should match files and what it should do once it finds them. This is where much of the complexity of the command is found. You can search based on the file name, the modification time, the type of file, the file's permissions, and many more criteria. For our example, we are just going to search based on the name. Let's say we want to find text files that start with the word file and are in the current directory or its subdirectories. The command starts searching in the current directory as denoted by the period. It then searches for files that start with the word file and end in text. If you remember from a previous video, the asterisk is a wildcard that expands to 0 or more characters. Since you are using a wildcard, you need to put the pattern in quotes so the command line knows you want to use the wildcard for the pattern that is sent to the find command, and not to interpret it before it sends it to the find command. Note that the find command uses this pattern exactly. Since Linux is case sensitive, it will not find any files that differ in case, like a file that starts with a capital F. If you want to perform a case insensitive search, use iname instead of name like this. Notice that we found a few more files by using it. Another command we can use is locate. Locate makes use of a database to find files.
So let's try to. Well, let's be more. Pin 2, 3. Okay. Found those. Two, three. Ping 2, 3.
The database is normally updated every day in a cron job. Since it uses a database, the locate command can be faster and easier to use than find.
Okay, what?
Equally updated. Another command we can use is locate. Locate makes use of a database to find files. The database is normally updated every day in a cron job. Since it uses a database, the locate command can be faster and easier to use than find. If you know the exact string to search for, the syntax is very simple. Notice that we didn't have to specify a starting point. the search will return results from the entire file system. If we want to search based on a pattern, we can use wildcards just like the find command. As with the find command, the locate command has many more options. I suggest you take a look at them in the man page.
So if I were to do this, my locate file isn't working.
Don't feel like you have to memorize everything. I have been using Linux for over 20 years, and I'm not even close to having a lot of the options memorized. The important thing is to know what is possible and to be able to find out how to do it. The last two utilities we will look at aren't used for finding any general file. They are specifically used for finding commands. First, the which command displays the full path of the command with the associated name. Let's look at an example and find out which ls command would be executed. In this case, the path of the ls command is user bin ls, general file. They are specifically used for finding commands. First, the which command displays the full path of the command with the associated name. Let's look at an example and find out which ls command would be executed. In this case, the path of the ls command is user bin ls.
It's a text file.
Initially, this may not seem that beneficial, but there are specific situations where it is very useful. For example, if you are an administrator and think that there might be a Trojan with the same name as ls, you can verify that the correct command will get executed. We will discuss in a later video exactly how the command line determines which command is executed, so don't worry about those details right now. Next, the whereis command locates the executable, source code, and man pages for a utility. Here, we see that it displays the same path name for ls, but the whereis command also tells us which man page is associated with the command. Most of the time, the which command provides all the information you need.
Well, I feel like we should do some digging. Okay, this is like really broad. Mm, does not like me using that. Alright, let's just do something crazy like touch Drake MP3 and I put it Alright, we're gonna try to locate a file called love songs. And unless I'm mistaken, I cannot find it. So find love. And I don't remember what I named it, so okay. Oh, I had two. And I found them. Alright, I think that's gonna be it for me. Um, next time we'll do compressing and archiving files. installing software, shells for utilities, text editors. Like tempted to say screw it and just get with it. It's gonna be about tar balls. How long have I been streaming? Yeah, I think I'll leave it there for right now.